In this video, we are going to do the fourth example for systems of equations. And so we're doing some nonlinear. And so it's always kind of good to see what kind of graphs you got going on here. We have a circle because it's positive. Well, this one's positive as well, but the difference between it is the coefficients match each other here, which makes it a circle, as opposed to these two not matching. And so you're going to have an ellipse on that one. So you're going to have a circle on the top one and an ellipse on the bottom. All right. So we're going to graph it eventually, but right now I'm going to try to just algebraically solve it, and I could do substitution or we could do elimination. This one kind of has a nice elimination feel to it. Maybe we'll cancel the y's. So we'll multiply top equation by a -9. So if we do that, that's going to get us a -9x squared minus 9y squared equaling -36. And then we didn't do anything to the other equation. All right, and then we'll combine our like terms. So the y's go away. This gets us a 7x squared equaling 108. And if we divide by 7, we're getting x squared equaling, I don't know. They don't go into each other. So 108 over 7. All right. And then we'll square root both sides. So we'll have x equaling plus or minus the square root of 108 over 7. Now I'm going to eventually turn that into a decimal, but for right now, I'm just going to plug it in to one of these and kind of just see what happens. So let's say we take that and plug that into the top equation. In fact, I can go back to this x squared piece and say x squared equaled 108 over 7 and replace our x squared here. So if I'm taking x squared and saying it equaled 108 over 7, that means on this equation we would have y squared, or we'd have 108 over 7 plus y squared equaling 4. So if we're going to put all this together, we're going to be subtracting 108 over 7. So I'm going to take the 4 and just think of it as 28 sevenths that I'm going to subtract 108 sevenths. So we're looking at y squared equaling, I don't know. I know that's going to work out decent, but so 28 minus 108 is -80 sevenths. And we are about to have a problem because we're going to square root both sides. So because we're square rooting a negative, we're going to get imaginary, and that shouldn't really happen on these. So that's telling me that we are not getting a solution. So let's see what happened. So we're going to graph a circle and an ellipse, and apparently they're not going to cross each other. So the circle's nice. It's centered at 0, 0, and your radius, because this is an r squared, your radius is 2. So you got a circle that goes 2 in every direction from the center. And then our ellipse is not ready to graph, so we're going to do some adjustments to make that one ready to graph, to get it into the standard form. All right, so this needs to equal 1, so we divide by 144, divide by 144, divide by 144. And so 16 goes into 144 9 times. And then 9 goes into 144 16 times. And it equals 1. So this is your a squared value. This will be our left and right. So a squared equals 9. That makes a equaling 3. So from the center, we're going to go 3 in either direction. Your b squared value is 16, which makes our b value 4. So you're having a vertical ellipse because you have more up and down than you do left and right. And we knew that kind of from this, the 16, the value under the y squared is bigger than the value under the x squared. So more up and down than left and right. And if you graph your ellipse, they don't cross each other. So we do in fact have no solution. All right, and that was the fourth example of solving nonlinear systems of equations.